So we'll get started. I want to sort of talk about the cast of characters. We're talking about network firewall configuration, allowing and permitting and denying flows. So there's three main kinds of people that are interested in this. One are the users. These are usually developers or someone like that, who are requesting flows and requesting access to different resources. Another is the InfoSec team, who probably wants to make sure that you're using a firewall to protect your systems. And the third is NetOps, the people who are actually configuring the firewalls and responsible for maintaining network performance. So as we go through this, we'll sort of see those three different interest groups, how they relate to this project. So before we get started, I want to talk about some of the motivating examples for testing your firewall flows. So one of them is when you're getting your requests from a user and there's some confusion about what a flow is, what flows are requested, what flows are needed. A user might say, please open this particular port between these particular hosts. And they don't have, other than going and trying it, a good way to test if that's possible. They may want a whole set of hosts to a whole other set of hosts, and that's a lot to test. The NetOps team goes and logs into the firewall and sees, oh, that should already be open. So they close the bug as works for me. And then maybe it was already open, maybe it wasn't. But there's no good way for someone to sort of see what that flow is there. Another is bugs where your configuration flows are incorrect. So you make a request to say these database servers should talk to these web heads or vice versa. And NetOps goes and implements that, but they don't quite understand what you meant. Maybe they didn't realize that you wanted the staging to talk to production or something silly like that. So they close the bug, and then you fire it up in production or in staging, and something doesn't work. So there's an extra conversational round there where you go back and you say, well, actually, this doesn't work. Here's what's still not working. Can you go back and fix that? Sort of adds some friction to this conversation. Finally, sometimes when you're deploying new changes, you have a particular request. You need to set up these new firewall flows for this new service. And you go to NetOps, so you're working in your specific, as a user, your specific environment. You know what your web heads are. You know what your database servers are. You know what your Rabbit servers are. And you say, hey, I need the web heads to talk to the database servers on this port. And they say, well, we've got 300 database servers. Which database servers exactly are you talking about? So it's just a difference of perspective there. So, but another conversational round, some confusion about what these flows should be. We also sometimes have outages. So NetOps might be reconfiguring things to get more efficient or higher bandwidth or something like that, or they're satisfying a request for a flow from another group, and they accidentally typo something or make a change that affects your flows, and suddenly your production system goes down, and you file a bug or you get in touch with someone and they say, oh, I added that to the wrong zone. I'm sorry, I'll back that out and fix it. But we had a production downtime there, so that's easy to miss. We also have what should be trivial queries. So these are often related to audits, but often people just want to know, hey, I just became aware of this, or became responsible for this subnet. Can you just kind of give me the lay of the land on what flows we're allowing here so that I know where to go from here? And really, that should be a pretty easy question to answer. But in many cases, with firewall configurations being what they are, that's a multi-month project, and we're looking at live traffic. We're just doing some parsing of the configuration. It's quite a lot of work there. So we want to get a better visibility into firewall flows, essentially. We want it for our users so they can know what they're getting. NetOps wants it so they can know what they're responsible for on a continuing basis. And InfoSec wants to know that the things that most need to be protected are protected, and that we have the necessary restrictions in place to protect the infrastructure. And the best way to accomplish this is automation. So the automation that we built at Mozilla is called Firewall Unit. So we'll talk just briefly about what Firewall Unit is as an overview here. The idea is that we gather data from all of our firewall flows, from all of our firewalls and all the other things that are controlling flows. We gather that, put it in a data structure, and we support some dynamic queries against that data, so you can very quickly learn what's allowed, what's not allowed. And we support some automated verification that things are the way we expect them to be. We'll get to talk about how each of those works in just a minute. But before we do, I want to talk, a sort of principal objection here is there's dozens of commercial tools out here. And this is something and I should introduce our teams here. Michal is in OPSEC, and he does a lot of the network, the flow analysis, and is responsible for kind of making sure these things are right. So he's looked at a lot of these commercial tools. I'm a user, largely, making these requests and hoping that the flows that I have in place don't get broken by something. So he did a lot of evaluation of tools in this area and found them all lacking in a number of ways. One of them is the commercial tools. They support all the firewall vendors. They support all the different cloud providers. They support all these tools that we don't have. We're a fairly large organization, but actually in terms of our network infrastructure, we're fairly homogenous in terms of brands. We pretty much use Junipers, and we have a lot of Amazon presence. So we're paying for features we don't need. We're paying for complexity we don't need if we use those projects. They also can't combine policies. So if you have some firewall configuration in a data center in Phoenix and some firewall configuration in your New York data center, these don't have a good way to look at routing tables and figure out how to put those together in a cohesive view of your network. They don't scale very well, kind of surprisingly. One of the tools we were working with would take 40 minutes to respond to a simple query to say, does host X have access on this port to host Y? It would generate a whole report for all hosts and all ports, and then you could look in that report for that particular host. 40 minutes is a long time to answer a pretty trivial query. Which product was that? I actually don't know, but I'm sure Michal would rather not say. Also, good luck scripting them. We're sort of sysadmins at heart, and we want text files. We want easy to parse stuff. A lot of these have XML interfaces, some weird APIs. A lot of it's proprietary, and you can't get access to the data other than by screen scraping. And often the compliance rules that they'll check for are hard-coded to well-known public compliance suites. And Mozilla worries less about those than most organizations. We're weird. So we have weird compliance things. We want to comply with our own rules, not with something that comes from a government body or something like that. And like I said, we want to use Vim. We want to use Bash. We want something that works on the command line and fits into our other tooling there. So this is kind of why we've rejected commercial tools for this process. So I want to give a little bit of a demo of how Firewall Unit works here. And this is the part, Michal has recorded the demo for these. So if the demo guides are smiling on me, we'll hear the audio from him. But this is kind of a taste of how Firewall Unit works in practice for doing a couple of things it does. The first we're going to look at is, querying flows. So we've already gathered all the data, and we're going to look at exactly what flows are and aren't allowed on the command line.
Let's see how does the firewall unit query work. So what I will do is I will ask the database to tell me if several flows are permitted or denied. Remember that firewall unit always builds like a database and sends queries to this database. It is not a live query. That would take way too long. So in this first example, I'm asking if an Office subnet here can access SSH servers in some other offices. So the firewall unit query command is followed by the query type. Here it is permitted, because we want to know if the flow is permitted or not. You can see that firewall unit actually translated this query into some kind of internal language, and it's showing us in a verbose mode what it's doing. It found no rule that would permit such access, so the query failed because we were looking if the flow is permitted. So it says it's not, and the return code to the shell is like 1. Also, you can see that the firewall unit is really fast because it did it in less than 2 seconds, where some of the commercial products would require me to actually use like 40 minutes to do the same job, like creating a report and then putting the report back into some kind of engine and answering after like 40 minutes, sending me a PDF. So let's see another example. Here we will ask firewall unit if the Office subnet can access Google DNS caching servers. This time firewall unit found a rule to permit this flow and is showing us the name of the Juniper SRX firewall policy, which is, in other words, the rule name. we can see that the rule allows access to everything in the internet except a handful of so-called private addresses. The error code this time is 0. So the query succeeded because we were asking if the flow is permitted, and the flow is permitted. And the query was again really fast, like 1.5 seconds. So in another query that I'd like to show you, we are asking firewall unit if an office network can access a subnet in a data center, right here, where databases live. Fortunately, we don't have any such rules, so for the application MySQL, firewall unit told us that no, the office network cannot access databases in the data center. These are not the only ways you can query firewall unit. You can, for example, ask it, okay, I want to know all of the applications that are permitted between subnet A and B, unidirectional, so it's from subnet A to subnet B. You do it like this. Let me scroll up, and you will see that the command this time is like the previous one, except that we use the keyword apps. And we follow it by the rule set name and the source and destination subnets. And for them, firewall unit will combine all of the policies that are important for this flow that could be permitting or denying these flows. You can see it right here, and it will produce a long report of all of the applications permitted from subnet A to subnet B. Firewall unit combined a few policies to answer our query. All of them are responsible for some flows to be opened, and when combined, they provide a coherent answer that is returned. So let me do one more query, and here you will see that, for example, from this subnet to this subnet, it's from one of the office subnets to, I think it's a DMZ. No of the applications are permitted at all. So firewall unit will just return like an empty list here.
So thank you for your patience listening to the audio like that. It's a good way to make sure he can participate, and he is the one using this end of the software, so he's certainly a better person to demo. The next demo of the two here is comparing flows over time. So one of the neat things about having this kind of data store of your firewall configuration, your flow configuration, is you can keep multiple copies of that and see what the differences look like.
Firewall unit diff is a very handy tool to compare flows over time. Because in our configuration, firewall unit builds a rule set database every single day, we can easily create like a time machine that shows how the rules change over time and can be queried for arbitrary points in the past. So let's see how comparing flows works. Here in this example, we use like two databases. You give the database files to the firewall unit command line. And we will use two databases of rules from the same firewall. One is like a few weeks old, and another is like a current one. You can see that some of the new rules were added. For example, right here, you can see that from this subnet to this very host, the flow has been added to permit SMTP application. So this SMTP application is now permitted between this single subnet and this host. And it took only around half a minute to compare several weeks of rule sets.
So that's a great tool for monitoring what's changed and being able to correlate that with either intentional changes or surprising changes or unintentional changes. So that's the network, and the configuration of flows is sort of this shared evolving state that these three characters are all interested in. Users want to make sure that on a continuing basis, the flows that they need are open. OPSEC wants to make sure on a continuing basis that the flows they hope aren't open, say from the office to the database servers, continue to not be open. And the network operations team, they want to make sure that, the changes that they make shouldn't affect either of these kind of desirable flows. So we have this kind of behavior that all of us expect to continue, even though we have an evolving state. And DevOps has learned a lot from software development. There's a lesson here as well. Software would solve this same kind of problem where you have an application, a body of code that is evolving, but you want it to continue to have certain behaviors. We solve that with testing. So we start with, either in software or in network flows, we start with the behavior, and that might come from user requirements, or it might come from internally developed desired behaviors. And what we do is we interpret that behavior in two different ways. One of those interpretations, and if you're doing test-driven development, this is the first one, you interpret that into some tests that represent how this software or these flows should behave. The other interpretation is into the actual implementation of it. So in a network sense, this is actually changing the configuration in your firewall, in your Amazon security group. And the neat that you're interpreting this twice, and if you're interpreting it with two different people, you're at a win there, because there's some conversation about exactly what behavior do I want, which hosts did I mean, what ports exactly was I looking for, that sort of thing. But we also have this mechanical verification that these two interpretations match. So this gives us a high degree of confidence immediately that we've interpreted the behavior correctly, and it also gives us an ongoing way to make sure that these two interpretations stay in sync. Right? If the flows change, the test should fail. If the tests change, the test should fail, if they change in an unexpected or undesirable way. So we implement this with unit tests, and I put this up here and I feel like I'm giving a talk about writing a Python unit test. This is actually kind of really simple stuff, but it's really powerful. This is just a Python function. It's for any Python programmers, this is probably very familiar, but for a programmer that's not a Python person, also very readable. It's just a function. It has a nice unique name, so if you need to refer in an email or chat to a particular test, the case that you're talking about, you have a handle for it. The next two pink lines there are a documentation for it. It's just arbitrary text prose. Here it gives an idea of what this is talking about. So worker managers have outbound access. This sounds like something that the developers, the users, are interested in. They want a flow open. And it has a link to a bug there, or a bug number. And at Bugzilla, at Mozilla, if you see that, you go look in Bugzilla for that number. And you can find some of the history of why this flow was requested, who requested it, who implemented it, when it happened, that sort of thing. And then the last bit there is just an assertion that a particular flow is required, or should be open. And it's from the worker managers to 3 different VLANs, which look like they're in Amazon, US East 1 and US West 2. And the application in this case is SSH. So we want to make sure there's SSH access. So those names, we're not putting IP addresses in here, or IP ranges, or CIDR notation, or anything. They're names. They're very memorable names, but they're just Python variables. So we define those in network.py, just a single Python file that applies for all of our unit tests. And we can describe them here in CIDR notation, so our subnets are more than one host. But for specific hosts and servers that have a permanent address, we can either look them up by DNS, or you could certainly, if you're worried about DNS poisoning, you could certainly put a straight IP address in there. But this gives us a nice named handle to refer to a set of servers or a set of subnets or anything like that. And this is kind of an example. So here we're gathering a bunch of data. This one goes by really fast. We run the tests. And you see one of these tests has failed here. The details of this aren't particularly important, but it's a failed test run. So we go in and edit the tests, and it looks like I just had a typo in one of the IP addresses there that I was checking for. Run the tests again, and we have 5 passing tests. So this is the kind of demo from the GitHub page, which is why it's very fast. But that's the basic idea there. It's just like any other Python project. You're just running nose tests to run these tests, and it's got this data that's already been gathered from all of the firewalls. And this gives us a whole bunch of useful information. So we can do a little bit more here. If we want to increase this visibility of what flows are and aren't allowed, it's that first use case, that first motivating example. Arguably, we haven't done much for readability here. So the NetOps team can probably read the top part of that. That's a Juniper firewall policy. And a programmer, or a user, or developer can probably read the bottom part of that. It's pretty much just a function that calls something. But neither of these really gives you a nice overview of what these flows are. You don't want to be searching through either one of these. And neither one of those teams can read the other one very well. NetOps probably isn't full of programmers, so the bottom part might not be so clear. And developers certainly aren't configuring firewalls in most cases. But we had that doc string, and Python happens to let us write a documentation string at the top of a module as well. So we can write a little bit of prose for this module is about the workers that are, I guess, doing work. So we write a little bit of prose about generally what they do, what their flows are, and then we saw that doc string on each test case, and we'll have multiple test cases in a file. And we can pull those out and put them into a nice HTML document. So this just goes on a wiki. Well, it's not a wiki, it's an HTML document, but it's available for people to look at when they want to know, is a flow open? And that's a pretty basic idea, right? You can say, well, we document all our flows, but this is verified to be correct, right? Every night, we run all those tests, and these documentation came from those tests. So as long as that doc string and the lines right below it that assert that same thing in code still correspond, which is pretty easy to ensure when you're writing code, we know that this document is correct as of this morning, the last time these tests ran. So we're not worried about looking at a document and saying, well, I see this was last modified 3 weeks ago. Did something change since then and they forgot to update the documentation? Not a problem here. So given all that, I want to talk a little bit about the design of firewall unit. There's some neat features in here. And when I started writing this, I kind of thought back, what's the simplest possible implementation of this? If you want to know if flows from one IP to another IP are allowed or denied, you basically take a matrix of the entire IPv4 space down the side, across the top, and then where those meet, it's either allowed or denied. It's a Boolean value for each one of those. Pretty simple, and there's relatively easy ways to represent this efficiently in Python, or in any language, really. We need one of those matrices for each application. And applications are sort of like port numbers, but we fudge that a little bit because firewalls fudge that a little bit. So our Junipers have ALGs, which will represent the multiple ports that FTP uses as a single application. It's simpler to talk at that level. So we'll have one of these matrices for each application. Oops. And then we have sources, which can generate these matrices. So one of the sources that we use, I've been talking a lot about Juniper SRXs, is one that logs directly into each of our firewalls, has an SSH connection and a key in there. And it looks at the security zones on that device, it looks at the route table on that device, and it looks at the firewall policies that are in place on that device. And basically pulls that all out, does a whole bunch of arithmetic with the IP spaces and the allows and denies and all of that, and out pops a matrix here. So one of the interesting bits about this is that we use, if you know Juniper, we use show security policies rather than show configuration security policies. In other words, we're looking at the actual set of rules that are getting fed into the hardware forwarding engine rather than looking at the configuration file that humans typed in. And the reason we do that is we want to avoid emulating the conversion from that configuration file into what's actually stopped at that firewall and what's not stopped at that firewall. So we want to get as close to the metal as possible. And as I said, we also use Amazon EC2, quite a few hosts in there. So we have a similar tool which can pull data from EC2. It just looks at the security groups and the subnets and the instances that are in those subnets and does some arithmetic and out pops a matrix. And the cool thing is we can combine sets of matrices together. So if you have, for example, the data center in Northern California and one in Dallas and one in DC, and you have a firewall in each one of those that's controlling flows within them. So within Northern California, from IP to IP, only that one firewall in Northern California is relevant. But if you have a flow that's going from Northern California to DC, that may stop off in Dallas, then all three of those firewalls have an opportunity to filter that packet. So we need to apply each of the matrices from each of those firewalls. So we feed this a little bit of routing information as to what IP space is controlled by which firewall, and then give them the sources for each of those, and it combines them into one matrix. So this does assume that we have a flat IP space, that your organization doesn't use the same IP address in multiple locations. Happens to be true at Mozilla, and is true in a lot of places, but certainly not everywhere. But we get this one data source, and this is the one we can write our tests against. So I can write a test about a flow from data center to data center without worrying about any of that when I'm writing the test. So let's quickly revisit some of those motivating examples. We had users wondering if a flow is already open or if they need to request it. And that documentation provides a really great way to answer that question. It's prose, has links to bugs if you want to see the details. It says exactly what is allowed and what is forbidden. When NetOps is implementing a new request, we're not quite there yet, but ideally people would request a flow and provide the test that should pass once that flow is implemented. So here, NetOps can implement the new flow and then run the tests, including that new one. If everything passes, they've done it right. If one of the existing tests fails, but the new one passes, they've messed something else up in implementing this new one. Or if the new test doesn't pass, then they've implemented that incorrectly. Again, this question of what do you mean by database server? We have so many database servers. That hosts file provides a nice single name for the servers that I'm talking about. So again, if I give you a test and it refers to a Python variable, you just look up the IPs or host names that corresponds to, and you know unambiguously what that user is asking for. When we're refactoring or changing routing or something like that, did we break something? Run the tests. After you've made your major refactor, you've changed how things are configured, run the tests. And if they all pass, all of the behaviors that are expected of you are still implemented. And those general queries, we saw a good example of firewall unit query being able to tell us ad hoc, can this host talk to this host or this VPN, this network talk to that network. But we also have the documentation. So in many cases, an audit at Mozilla is a little less formal than most places. But if someone says, what has access to this subnet? Well, there's probably an HTML page out there that has exactly the answer to that question already, and we don't even have to run any commands. Just point them at the page. And like I said, that documentation is verified to be correct. So I want to talk a little bit about future work here. And as a warning, there's a couple memes coming up here. You may have gotten from what I said that we're pulling this data live. So if you want to make a change to the configuration to add a new flow that's been requested, and then you want to run the tests, the process is implement the flow live in production, run the firewall unit data gathering stuff to go and gather that into this data store, then take the tests, run the tests. And that data gathering actually takes over an hour. Junipers are really, really slow on the control plane. So the tests fail, you find out, well, okay, for over an hour now, I've had something broken in production, oops. There are some ways around this, but they all involve compromise. So we might have to compromise this sort of pulling from the bare metal on the firewalls, or we may have to compromise on only talking to live systems. We could have a staging system that we talk to, that we put the configuration into, and then pull the data back out, even though it never handles live traffic. So far, this has been doing okay, but we're going to run into this problem pretty soon. And the next one, Mozilla actually does do quite a bit of IPv6. A lot of our public sites are dual stack right now, and we actually have some penetration into our back-end systems. But release engineering, the group I work in, doesn't do IPv6 at all. And we have a large presence in Amazon, and Amazon doesn't do IPv6 at all. So this isn't really a thing for me. But in principle, it wouldn't be hard to add IPv6 support to this software. It's just a larger matrix, but with a representation, it actually wouldn't take any more space. So stepping back from firewall flows to the more general question here, we have a lot of cases where we're doing access control for things. So many of you have probably had the misfortune of managing an NTFS shared directory at some enterprise. And the HR department wants to know that these people have access to the payroll database, but only these two people can edit it. And this other group wants these permissions, and this group wants a Dropbox. And the UI for configuring these things is mind-blowingly complex. That advanced button still gives me nightmares. So when someone asks you, can you make sure that only these people have access to this file? Or it turns out this person was working for our enemy, can you tell me what files they had access to? No way to know, really. That's a 3-month project or a 3-day project at least. Could do the same thing here. You could scan all the ACLs on that drive, put them into some data structure, do all the arithmetic the NTFS does with inheritance and all that stuff, and then write some unit tests against that data structure, right? So write a unit test that says that these 3 people are the only people with write access to the payroll spreadsheet. That's when you'll find out that your sysadmins have write access to that payroll spreadsheet. Maybe you tell them, maybe you don't, I don't know. So this is sort of one example here, but you can probably think of lots of other access control examples where this approach could really be useful in being able to give a lot of assurance that things are still correct, a lot of assurance to people who are worried about what the access levels are, and that you haven't messed something up when you're configuring them. And we are actually doing this with a tool called Task Cluster. So this is a new process at Mozilla that we're using to do, it's a continuous integration system. And we're a very open company, so on the one end, this is willing to let any of you who are interested in writing a patch for Firefox with very little authentication, you can use Task Cluster to build your patch for Firefox on Android and Mac OS X and Linux and Windows and test it. You can run about 3 or 4 compute days worth of work on your patch, basically with almost no knowledge of who you are. Give us an email address and you can do it. All the way up through release engineering using this same system to build, test, and release Firefox to 500 million users. And there's cryptographic signing in there. There's a whole bunch of other kind of very sensitive stuff. Same system. So you can expect we have a pretty sophisticated access control system built within Task Cluster so that we can limit, all of you can't sign Firefox, but all of you can run your patch. And it's complex because it needs to be complex, but it also means that it's difficult to reason about it in your head. It's difficult to sort of look at the configuration and say, yeah, I can tell that's safe just by looking at it. So we're going to do the same thing. We're going to write a bunch of tests that take all of the access control lists in the system, do a little bit of arithmetic, and then we write tests to say, you can't ship Firefox, I can ship Firefox, but you can still run your tests, and you have what you need to do that. So as a principle, I think this is a useful idea in a lot of different access control and security areas. And that brings me to the end. There's the URL for Firewall Unit. It's Mozilla, so I thought it went without saying that it's open source. And Michal's contact information and my contact information. And I'm happy to take questions. I think we started a little late, so we have 10 minutes. Microphone's up there.
Great tool. You specifically focus on like Juniper SRXs. Not everybody might be using those. So you will have to develop against it, or you've already implemented various templating?
I haven't implemented for any other platform, but it wouldn't be difficult.
Okay.
We just don't run them. So I don't have a reason, we don't have any Cisco firewalls or anything like that.
Okay.
So
it might not be firewalls. You can pretty much do the same thing against ACLs, right? It can be Juniper ACLs or Cisco ACLs or Arista or whatever.
Yeah. I see. Specifically SRX ACLs is what you're asking about?
I mean, it can be an ACL on a Juniper MX480. It doesn't matter,
Yeah,
right? You're just looking at policies.
Absolutely.
And basically mapping them to what's permitted and what's not permitted.
Yeah. And I'm not at NetOps, so like I learned the minimal amount about that I needed to, which is the firewalls that we have that I run into.
Okay, awesome. Thank you.
Yeah.
I actually have 2 questions. Number one, in the demo, they were showing checking for flows between 2 networks. Suppose I had, rather than a /21, I think a /24 in there, suppose I had 2 /32s. That is 2 hosts were allowed through. Would searching for the supernet also give me everything that's encompassed in that supernet?
Yeah, and that's
Okay.
why you can query for allowed and you can query for denied, because those aren't necessarily the opposite of one another. Right? You can have, if you say allowed, then it's saying all hosts in this subnet to all hosts in that subnet on this port are allowed. Otherwise, it'll return a
Well, the question is,
state.
suppose I had one individual host on one network is allowed to one individual host on the other, but what I did was I searched for allowed between their supernets.
Right.
It would still return those 2 guys as being allowed connections, even though the entire network itself is not allowed.
The query would return false because everything that you've asked for isn't allowed, and the logging would
so
indicate
you have
those 2
so you have no idea of something under. You have to basically make your query specifically to match the policy rule.
You have to make the query specifically what you're interested in. So if you want to know that everything is allowed between these, then ask, is everything allowed? If you want to know, is everything denied between these, ask, is everything denied between these? And if the answer is no to both of those,
Okay.
then there's something you don't know.
So I was
you need to
looking
look
for,
what
if I was
else.
looking for 2 hosts, I'd have to say, is everything denied? And if the answer is no, and those
Yeah.
guys showed up, then it would be allowed. Okay.
Exactly. The verbose logging will give you a hint as to what those hosts are.
The other question I had is, I know one company that changed their firewalls. They went from Cisco PIX to something else, and they kind of screwed up the configuration. They didn't make it a one-for-one. However, doing something like TCP dumping or something like that and actually mapping what flows are allowed from actually watching the wire would probably have helped them significantly in debugging it and making unit tests out of it. Do you have any ideas along that line as to not necessarily querying the device, but actually seeing what's available and trying to infer what this matrix actually is?
Yeah, so we did a little bit of that. We took both approaches. And the problem with querying active traffic is, in many cases, you want your DR traffic or your backup traffic or some traffic that in production isn't normally happening, but
Right.
needs to happen during a failure situation. You won't see any of that even over a week's sample or a month's sample. We've run into that a couple cases at Mozilla where people in NetOps get weird ideas to, well, this flow hasn't been used in 6 months, so we're going to turn it off.
Gotcha.
That's an important flow. And actually, this tool has caught those situations. So I wouldn't necessarily recommend that. That can give you an idea of which of these are really important and which of these things in the old firewall config were wrong because they've never been used, and then you can think more about it.
Well, in this case, they actually broke active flows they would have seen if they were TCP dumping.
And it can definitely avoid
So,
that.
so
absolutely.
I'm looking for some way to sort of inherit a validation check of what we had before and what we have after is kind of the same.
Yeah.
The same deal, at least for what we see. Granted, your DR conditions we wouldn't know about.
Right,
I agree.
right. But
Okay.
you might see those in the configuration.
Exactly. Those should come out of the configuration. Except if you're not counting for Juniper SRX, you can't import the configuration.
Right.
How big is the average firewall policy that you're loading into this system? Like
On disk, the sort of the data structure that
Well,
I'm
I'm thinking
doing?
like number of rules, if you have that metric.
I don't know off the top of my head what the number of rules are.
we talking
I
hundreds,
think
thousands?
we started the sort of release engineering specific started with, I think, probably around 500. The sort of the rest of the organizations, I think, has about 1,000 or 2,000. It's a little bit more, just because there's a lot of onesie twosies kind of flows, and we've consolidated our flows into larger subnets.
And can you answer the question if a user says, I can't get from A to B, and I'm sure this worked a month ago. Can you tell them whether it actually was permitted a month ago?
Yeah, so we keep, right now we're keeping half a year's worth of daily snapshots of this data structure. So we could go back with that firewall diffs tool and look at maybe when that particular flow had changed, if ever. Or if they said it worked a week ago, we go back to a week ago's database and run a FW unit query against that and see, is that correct? Not that I'm going to argue with a user, but might learn something about what they're suggesting at that point. Go ahead.
So if I'm understanding correctly, there's still a disconnect between the testing and the deployment, right? The NetOps are still logging into the SRXs and applying the rule that was submitted. Is there any plan or roadmap to combine if the unit test pass, automatically push the submitted and tested config rather than having this fork between
Right.
what was tested and what was applied?
Yeah, well, it's not even a fork. You deploy it first and then you test it. It's exactly in the wrong order.
yeah.
I would like that, but I don't work for NetOps, and that falls pretty squarely in NetOps to change their procedures, and they have other priorities.
Okay.
So I would be interested in building and supporting this tool for that if there was interest in using it, but it's not driven right now.
But if you were to do that, wouldn't that require you to actually do the very conversion you don't want to do, which is from the configuration languages written by the human to the actual running configuration? And you said you didn't actually want to do that.
Correct. Yeah, so I see two options here, and there are probably more, but one option is what you're suggesting. I would take configuration files out of version control or something like that, figure out what policies those would end up putting into the forwarding engine, and then simulate those. And we'd have to do something similar with security groups in Amazon, right? Maybe a CloudFormation JSON file that I process. That might be easier. So there's a disadvantage to doing that. But another option is at least Juniper's there are emulators for that you can run in a VM. I'm not sure of the legality of that. And certainly you can get a staging piece of hardware that doesn't do live traffic, so it could be a very a
It
low
just
end
acts as your
SRX.
compilation engine.
Yeah, so we'll put the config on that as sort of staging, and then pull the policies back out of that. And if that succeeds, then we'll push the config to the production firewall. So either of those would be options, but they both have expenses.
All right.